The next section is quite short. It's a continuation of section 2.1, and we're talking about finding the mean specifically from a grouped frequency table now. So remember from the previous video that the mean from a frequency table is calculated using this formula, a variation on the standard mean formula where x bar is the sum of the frequencies times by the x values divided by the total number of values, which is just the sum of the frequencies. So this was analogous to n in the original formula, and this is analogous to the sum of x in the original formula. So you use the sum of x over n when you have a list of numbers, and you use this formula when you have a frequency table. What happens if your frequency table is grouped continuous data? So first thing we need to remember with with a grouped frequency table is that we have to change the limits of the classes so that there's no gap between them. So we've got this gap from 31 to 32 we're going to fill in. So this class really goes from 29.5 up to 31.5. This one 31.5 up to 33.5. This one 33.5 up to 36.5, and this one 36.5 up to 39.5. So we have the upper and lower bounds of each of the classes. Let's just copy the frequencies from the table in the book. Now the table in the book is presented horizontally, probably for space saving purposes. So I'm doing it vertically here because I think it's a little bit clearer for showing you what happens next. It's a bit more familiar from what you've done at GCSE. It really doesn't matter, you can do it either way. So the question here then is, if we're asked to find the mean, we've got to do the sum of the frequencies multiplied by the x values. Now in the previous example, the x values were the values in this column here, but now we've got groups. So for our x values, we take the midpoint of each group. Now we looked at this in one of our earlier videos from chapter 1, finding these midpoints, and we pointed out that the midpoint from 29.5 to 31.5 is of course 30.5, but that's the same as the midpoint from 30 to 31. So for the purposes of finding the midpoint, you don't need to work out these upper and lower bounds, but with lots of the things that we do throughout examples like this and throughout the course, we do need to have these upper and lower bounds. So it's worth always putting them in just so that you make a habit of it. So the next one, we've got the midpoint from 32 to 33, so we've got 32.5, which of course is the same as the midpoint of 31.5 and 33.5. The next one we've got is the midpoint of 34 and 36, so that's 35. And the last one, 37 to 39, so that's a midpoint of 38. So these are our x values. Now, I'm going to do these slightly out of order. We'll stick with the mean while we're on it. So part B was find the mean of these data. So x bar is equal to the sum of fx over the sum of f. Now I want to point out here that the formula says, that the equal sign here I've put is an approximately equal to sign. Now the reason for that is that when we have group data, our mean is always an estimate. So strictly speaking, I should have put approximately equal to there when we're dealing with a grouped frequency table. Now, why is it an estimate? It's an estimate because we know that there are two data values in this class, but we don't know what they are. They could both be 29.5, or they could be two very different values within these two upper and lower bounds. Because we don't know what they are, we just assume that they average out at the midpoint at 30.5. They might not. They might both be lower, they might both be higher. We're assuming that probably one's a bit lower, one's a bit higher, and this is a good average of them. That's why this mean will never be anything other than an estimate. So you always see the phrase estimate the mean. It doesn't mean have a rough guess, it means do this process. But we know it's an estimate because we don't actually know what these two values here are, or what these 25 values in this class are. So the sum of fx divided by the sum of f here is going to be, let's work it out, 30.5 times 2 plus. In fact, I'm going to do this without the fraction button for now. 30.5 times 2 is 32.5 times 25. It's 35 times 30. It's 38 times 13. The reason I'm doing without the fraction button is because I want to actually write down the sum of fx here. 2417.5, just so I'm showing some working out, showing that I know what I'm doing. The sum of the frequencies, therefore, is the sum of the values in this column, which is 70. So that means, remember what it means in context all the time. This means that in this example where we're talking about the length to the nearest millimetre of a random sample of pine cones, we sampled 70 pine cones. So we have 2417.5 divided by 70, which gives us our estimated mean of 34.5 millimetres to 3 significant figures. Let's go back to part A. Asked us to find the mode or class. We can't give an individual mode because we don't know the individual values. The class that has the most, that has the highest frequency is this one, 34 to 36. Finally, we're asked to give the median class. It's not the actual median itself, but which class does it fall in. So remember we talked in the last video about finding where the median is located. In this case, n is 70. So if we do n plus 1 over 2, we're doing 70 plus 1 divided by 2, which gives us 35.5. So we're talking about the value that's in 35.5th position in our list of numbers. So the first 2 are in this class. Let's keep a little cumulative frequency going on here. By the time we get to the end of the next class, we've had 27 values. We've not reached 35.5th value yet, but by the time we get to here, we've had 57 values. So the 35.5th value was in the class 34 to 36. So the median, or Q2, is in the class 34 to 36. Now, that then leads on to exercise 2b, but I just wanted to quickly show you how you can use your calculator to get all these summary statistics. It's really important that you show your calculations like this, but there's a brilliant way on these calculators of checking them. So first of all, we're going to take a really simple list of numbers here, 2, 3, 7, 12 and 15. The value of n here is 5 because we have 5 numbers in our list. So if we wanted to find the mean, we could take the sum of all the x values and divide it by n. So we can add all these up. Let's do that quickly. That's 39 over 5. So that's just over 8, just under 8, sorry. So we've got 7.8 there as our mean. Now let me show you how the calculator does that straight away. Whenever you turn your calculator on, you are in mode number 1 here, the calculation mode. What we want to do is go to mode number 6, which is our statistics mode, so I can either navigate it to it with the arrows, or I can just press 6. And first of all, I just want this, single variable statistics. So I press number 1, and in this column here, marked X, I'm going to enter these 5 values. Equal sign takes you down to the next row. So I've got all my 5 values in. What do I do with them next? Well, I want to see some different statistics to do with these values. So I press the option button here and I choose single variable calculations. And it tells me first of all, I don't know if you can, how clearly you can see that, but try it on your own calculator. X bar is 7.8. The sum of all the x values is 39. These next ones you'll find out about soon. If we go down to the next row, it tells us that n is 5, the minimum value is 2. We've even got the lower quartile of 2.5. We've got the median of 7 and the upper quartile of 13.5, which is halfway between 12 and 15. And our maximum value is 15. So we've got all sorts of useful information about that list there. Remember, we got to that by typing in our values and then pressing the option button. Now, what I'm going to do next though, I'm going to clear this. I'm in single variable statistics, but what I would like to do is work with these data here. So I'm going to go to the setup. So I pressed shift and setup here. Second table down or second menu down and choose number 3, statistics. And I'm going to turn the frequency on. So now you'll see that I have my X column and my frequency column. So I'm going to enter in these data. The X values are these midpoints, the frequencies are these, always separated by the equal sign to bring us down a row. Now if I use the arrows, I can navigate back up to the first frequency and then enter that column in. So I've got my 4 rows of data all entered. So now if I go to option, and again single variable calc, I can see what I'd already written down. So my X bar, my mean, was 34.5 to 3 significant figures. Some of the X values, 2417.5. Ignore all the other ones for now. N was 70. Minimum value was 30.5. Of course, it doesn't know what the actual minimum was. It can only take what we entered. The maximum value on the next screen is 38. And it then gives us, these aren't so reliable, 32.5, 35 and 35 for our medians and quartiles. Those aren't so reliable because it's only taking these values. But for giving us the mean, and it has a way of actually checking that we've done a correct calculation, this is invaluable. So I would get yourself into the habit of working it out manually, but also checking every single one of your answers on the calculator. Okay, have a go at exercise 2B.